Okay, in this video here, we are talking about phase shifts of trig graphs, particularly just sine and cosine, but we might get into some other ones. So this is the part of our equation that we are looking at for the phase shift. Okay, all the ones right at the moment that we're going to give you are going to have parentheses, okay, but it could look like this, right, where your b value has been distributed. So just be careful, just because the x should not have a coefficient in it when we're looking at this form. Okay, the b should be pulled out. So let's identify your attributes of this function. Okay, the amplitude comes from the number in front of your trig word, so this has an amplitude of 2. Meaning your graph is 2 units above and 2 units below your midline or your horizontal center. Okay, the period is a calculation. The period is always 2 pi divided by the coefficient of x. In this case, since we don't see a number, we're going to call that 1 because there's always one of them for sure if there's not a number other than 1. So 2 pi divided by 1 is 2 pi, right? That's your standard sine and cosine period. The phase shift, so now we're looking in our parentheses. And because it's a minus, your phase shift is going to be pi over 4 units to the right. Okay, so we're going to shift our graph pi over 4 units to the right at the end. And there is no vertical shift, right? There's no number out here at all. So that is not applicable. In other words, the x-axis is going to be your midline or your horizontal center. Okay, so we could, if you wanted to, put a dashed line through here just to remind yourself that your zeros are where your graph crosses your midline. In this case, your midline is the x-axis. Okay, so now that we have all that information, let's get to graphing. We're going to start off by graphing a simpler equation than what we have. We're just going to graph 2 cosine of x. Okay, so we're taking out the phase shift for the moment, and we're not going to think about it. We're just going to graph 2 cosine x and get that basic parent graph in there, and then we're going to move our points. We'll do a phase shift at the end. Okay, so that's how we're going to attack this. First thing we do is we put our period on here. So we label the period. However far you want to go off to the right of the y-axis, we're going to put 2 pi as the label for your period. Okay, that's where the cosine graph will complete one full cycle. And then we'll go an equidistant past 2 pi. Where another 2 pi means I have a 4 pi at the end of my second cycle, or the end of my second period. So now to graph cosine. It has an amplitude of 2, so I'm going to start 2 units above my midline. Right? Cosine starts at a maximum value if it's a positive cosine. Cosine also ends at a maximum value if it's a positive cosine. So those are my starting point and my ending point for the cosine graph. Cosine starts and ends at a max. So the coordinate here would be 2 pi comma 2 because our graph is 2 units above the x-axis, or 2 units above the midline. Okay, some other things about cosine. In the middle of your maxes there, in the exact middle, cosine has a minimum. So this minimum would have a negative 2y value and a pi as the x value, because 1 pi is in the middle of 0 and 2 pi. Right? Most things happen in the middle or halfway on our graphs. Okay, so the next halfway is where it crosses the midline. It's going to cross our midline here and there, right? Halfway between your max and your min, we have a 0. And a 0 is the point where the graph crosses the midline. And that's one complete cycle for sine. Okay, so we're going to use a dashed line. And remember, we're going to have a nice smooth and curvy graph. Cosines and sines, sinusoidals are nice smoothie wave graphs. Okay, so if that's one cycle, we can continue using that pattern to get our second cycle, your second period, where cosine will have a max and a min, right? It's going to go to another 0, and then come down to another minimum, and then go back to another 0, and then end at another max. Okay, and likewise, going negative, we can have another 0 on the negative side of our graph also. So now that we have the basics, let's talk about how we do the real graph with our phase shift. So we're going to move all of our points that we have just plotted pi over 4 units to the right. Okay, and since I don't have any labels, right, I have two labels, pi and 2 pi, I have to decide how far is pi over 4 units. So let's think about the other labels. If this point is pi, then the coordinate here where the graph crosses the midline has to be pi over 2, because it always happens in the middle. And halfway to pi is pi over 2, right? Pi halves. So is pi over 4 bigger than or smaller than pi over 2? Smaller. Very good. How much smaller is it? It's half as small. So we're going to go in the middle of each one of these current tick marks that we've put on there. This is your pi over 4 distance. So we're going to put tick marks in between all of these other ones that are pi over 2 units long, just so we have all of the pi over 4 units. So now we've divided our horizontal axis into pi over 4 units. Every one of those tick marks is pi over 4 now. So I'm going to take each point and move it 1 tick mark to the right of where it currently is. Okay, this is how we're going to graph your phase shift. So our first point comes to here, right? And then your y-intercept is now there. Every black circle that we put on there is now moved 1 tick mark, or pi over 4 units, to the right of where it used to be. Right? We apply this to every single one. Every point gets moved pi over 4 units to the right. So these purple points represent the quote-unquote answer, right? The actual graph of our function with the phase shift. And then we connect these with a solid line, right? Smooth and curvy as best you can, so that it actually looks like a sine wave graph. Okay, so those are going to be our procedures for graphing all of these phase shift sine and cosine graph problems. Okay, let's move on to number 2. I'm going to change this pi over 3 real quick, because I did it before and did not like the way it ended up, to pi over 8. Okay, so we're going to change that problem as it was originally written from pi over 3 to pi over 8. Okay, because pi over 3 made some pretty messy things. And since we're learning, I don't want it to be that messy. Okay, amplitude is 3, right? And got positive 3. Our period, we're going to have to calculate. There is a number in front of x. So when we do 2 pi divided by 2, that gives me a period of pi. Right? So this has been horizontally compressed. What used to take it 2 pi units to go all the way around one cycle has now been compressed to just a single pi. Okay, phase shift will be pi over 8 units in what direction? To the left, right? Pluses go left, minuses go right. They are opposite of what the sign says. And then there's nothing after your parentheses, so no vertical shift. You have the x-axis as your midline again. Okay, so we could put a dashed line through there, knowing that that's called the midline. Okay, so we're going to graph our basic, and I say basic, it isn't really that basic. It has an amplitude change and a period adjustment. So we're going to graph 3 sine of 2x. Okay, so this is our graph without the phase shift. 3 sine of 2x. So we have a period of pi, so we come over an arbitrary amount and you put in a pi. Okay, and then you go that same arbitrary amount to make it 2 pi. Okay, it's a pretty good idea to use half of your horizontal line as the first cycle and then the end as your second cycle. Pretty easy to do. Okay, we're going to put 3 unit marks on the y-axis and 3 unit marks on the negative y-axis because we have an amplitude of 3. Right, it's going to help us out. Now let's think about how sine is graphed. The sine of 0 is 0. So sine starts at 0, right, on your midline. Sine ends at 0 on your midline. And sine has a 0 in the middle. This is how we graph a sine graph. 0 at the start, 0 at the end, and a 0 in the middle. Okay, in the middle of our zeros, because it's a positive sine graph, we have a maximum 3 units above your midline. And then we have a minimum between your next 2 zeros, 3 units below your midline. And that is 1 cycle for sine. We can connect these dots with a smooth curve with dashed lines, right, because we're not done. So let's put in a second cycle. We have a 0 at 2 pi, a 0 in the middle, a maximum value between your first zeros, and a minimum value between your second zeros, right? 3 units above as your max, and 3 units below is your min. And we could do a similar thing in the negative side, a negative 3 units, to get our basic sine graph. So now let's add in our phase shift. So we have to do pi over 8. So according to my labeling, what should my pi over 8 be? How far do I go according to my labels? Well, the 0 here is halfway, so that's a pi over 2. Because it happens in the middle. This is also happening in the middle, so that's a pi over 4, which means a pi over 8 is half way to pi over 4. So once again, half of 1 tick marks. We can increase our labels, so every one of these purple is now a pi over 8. Okay, and this is going to help us move all of our points pi over 8 units, in this case, to the left, right? Pi over 8 units to the left. So in other words, 1 purple tick mark, or half of our original tick mark, which was a pi over 4. So all the points move left, 1 purple tick mark, 1 unit, basically, 1, right? 1 pi over 8. Okay, which is why I want to see, right, your graph. I want to see your labels. That's why we practice labeling these things so that we can tell what are our units. Okay, because if you don't know what your units are, then these are really hard to do. We have to make some sense of how far do I actually have to go in order to make the phase shift phasable, not a word. And then connect your purple dots with a smooth, curvy line. Okay, and the purple is your final answer of 3 sine of 2 parentheses x plus pi over 8. All right, let's look at something that has all of the parts. Okay, our last problem here has all of the parts that we're ever going to have. We have an amplitude of 2. Let's calculate our period. So the period is always 2 pi divided by your b value. So 2 pi divided by pi over 6. Do we divide by a fraction? No, we switch and multiply by the reciprocal. So rather than dividing by pi over 6, I multiply by 6 over pi. And 2 pi times 6 divided by pi is just 12. So this graph has a period of 12. Okay, our phase shift is 3 units in what direction? 3 units to the left. Okay, our phase shift is always opposite of our sign, so a plus goes left. And then the vertical shift, we actually have one, we're going to go down 1 unit. Okay, so this is going to change our midline. Our midline is no longer going to be the x-axis, but the line y equals -1. So this is where our quote-unquote zeros are going to be. So we come down 1 unit, and we put a horizontally imaginary dashed line. Right? You don't actually see this. If you were going to graph this in a calculator, you wouldn't see this horizontally dashed line. It does not exist. The horizontal center does not exist on a graphing calculator. But it does help us graph it by hand. Okay, so now that we have that, we're going to come in here and put our period, which is 12. So we put a tick mark, right? However far to the right you want to go is 12. And then we make a current, right, the same length, and call that 24, right? That's the second period, kind of like our hours on the clock. Okay, this is the cycle. We're graphing a cosine, a positive cosine. So we're going to graph, to begin with, y equals 2 cosine pi over 6x minus 1. Okay, so we have everything but the phase shift. So cosine starts as positive, so it starts 2 units above your midline. Okay, 2 units above your midline is where we have our first cosine point. And then at the period, we have our ending cosine point, which is also at a max. So this would be the point 12, 1 would be that coordinate. Exactly halfway is where we have our minimum. So this would have a halfway to 12 is 6. This coordinate would be 6 minus 3. Okay, always halfways. And then halfway between our max and our min, we have where it crosses your midline. And then halfway between your min and your max is where it crosses the midline. So we could put our dashed line in for this cosine graph, and it would look a little something like this. Okay, so that's one complete cycle. So let's use that same pattern and find our second cycle. So exactly in the middle, we'll have our minimum. Exactly in the middle, we'll have our midline intercept. And exactly in the other middle, we'll have another midline intercept. So here's our graph of basic cosine. Right? Not really basic, but for our graph without the phase shift, that is our graph of cosine. Okay, now let's add in our phase shift. So we have to go 3 units to the left. So looking at my tick marks, which tick mark represents 3 units? And I believe it's only 1 tick mark, right? Because that's half of 6. Half of 6 is 3. For this shift, I don't have to add any extra tick marks. Every tick is 3 units away from the next one. So I just have to move each of my graphs 1 tick mark to the left. Perfect. So here's our new x-intercept, right? There's your new midline here. Every point is moving 1 tick mark to the left, because 1 tick mark represents 3 units. So we don't have to do any additional tick marks like we did on our other 2 graphs. Gorgeous. Okay, so then we connect all these purple dots with a nice smooth curvy line. A nice curvilinear line here, smooth and curvy, to the best of your little ability. Right, as a math teacher, I'm going to grade your math points, not your smooth and curviness, but I'm going to grade your math points. So hopefully your math points are spot on. That's what I'm helping to learn you. To teach you. English is hard. Okay, so there we go. Hopefully these phase shifts feel better and you're more confident about them. The final product should always be a solid line, and then potentially your middle steps would be a dashed line so that we know what it is that you are doing. All right, have a great day.